Electrolysis. When we pass electricity through a ionic compound in its aqueous or molten state, then it dissociates into ions. This process is electrolysis. So, electrolysis is the decomposition of a chemical compound in the aqueous or fused state by the passage of a direct electric current resulting in discharge of ions as neutral atom at the respective electrodes. So when electricity is passed in the molten state or diffused form, the compound dissociates, it conducts electricity. But remember, all compounds do not conduct electricity in their molten state or aqueous form. Those compounds which conduct electricity in their fused or aqueous solution, that are known as electrolytes. And those compounds which do not conduct electricity in their aqueous solution or in the fused form, they are known as non-electrolytes. Electrolytes are generally the electrovalent compounds, ionic compounds, and they have ions, only the ions in solution, or ions and molecules, some undissociated molecules. So they have ions or ions and molecules in their solution. This is very important to remember. This is asked in your exams. And non-electrolytes, they are generally the covalent compounds and they have molecules only in their solution. Now on the basis of conduction of electricity, that how much electricity they conduct, electrolytes can be categorized into strong electrolytes and weak electrolytes. Now you know that conduction of electricity is here taking place with free ions. So more free ions means more conduction of electricity, less free ions, less conduction of electricity. So strong electrolytes are those compounds which dissociate completely and produces large number of free ions. So they conduct electricity in a large amount. And those compounds which dissociate partly, they don't dissociate completely. So they produces less free ions and the conduction of electricity is less. So that type of compounds are known as weak electrolytes. So you have to learn examples of some strong electrolytes and some weak electrolytes. Now let us see this process of electrolysis. This is the apparatus in which this electrolysis takes place. This is known as electrolytic cell. So the device in which electrolysis takes place is known as electrolytic cell. Now you can see that in this device there are two metal plates or metal rods. Now instead of using metal, we can use graphite also, because graphite is also a very good conductor of electricity. So these metal plates or rods are known as electrodes. So electrodes allow the electricity to enter or leave the electrolytic solution. So through these electrodes, electricity either enter inside the electrolytic solution or leave the electrolytic solution. Now you can see that one of the metal plate is connected to the positive terminal of the battery. So this metallic plate that is connected to the positive terminal, this is called positive electrode or anode. And the other one that is connected to the negative terminal of the battery, that is known as negative electrode or cathode. So we have two electrodes, anode and cathode. Now when electricity is passed through this solution, then the compound dissociate to form ions. Let us take one example of sodium chloride. When electricity is passed through molten sodium chloride, it dissociates to form sodium ion and chloride ion. It means one is positively charged and other is negatively charged. Remember, positively charged ions are called cations and negatively charged ions are called anions. Now we know that there is always a strong attraction between positive and negative. That's why this positive ion will move towards the negative electrode, that is cathode. Means sodium ions will move towards cathode. And negative ions, anions, chloride ions, that will move towards the positive electrode, that is anode. So remember, A to A, C to C. A to A means anions to anode, cations to cathode.